Week 12, lesson 6. Okay, this lesson is review, but again, this got covered right after COVID struck, so I'm not sure how much of this actually sunk in. So I'm going to try to go through it, at a nice pace, but enough that hopefully you can follow along. All right, so first thing, just a reminder that this is the big kahuna, all right? It is a trigonometric identity that we use the most often. It's the main one, right? I'm going to call this number 1, but there are 2 other versions, all right, which you can derive yourself. If you were actually in class all the time, I would say to memorize them. But since you're not at home or not at school all the time and you're actually at home and can write things out, you might just want to write them down and have them nearby. So if you took this original equation and you divided every single term by sign, you would get another alternate version, which would, not sine squared. You would get 1 plus the cotangent squared equals cosecant squared. All right, and likewise, if you went back to the original number 1 and divided everything by cosine squared, you would then get tangent squared plus 1 equals secant squared. Okay, so knowing that and a lot of other information, let's see if we can do some of these examples. Okay, so this problem is saying, let's find the cosine if we know the sine and we know that x, which is the angle, is acute. Okay, so I'm going to draw a picture. You guys know me pretty well by now. If I can answer a question with a picture, I will. So if the angle is acute, right, it would look something like this. Since I know the sine, I know the opposite side and the hypotenuse. So it's pretty obvious that this is a 3, 4, 5 triangle. All right. And then I can find the cosine. The cosine of the angle is the adjacent side over the hypotenuse. Now, maybe you used the formula, right? There's a formula that relates sine and cosine. It's right here. So let's put in what we know. We know that the sine is 3/5. So if I put 3/5 here and square it, I should be able to solve this. This is 9/25 plus the cosine squared equals 1. If I move the 9/25 to the other side and subtract with a common denominator, I get 16/25. Now notice when you take the square root, you'll get 2 answers. It's plus or minus 4/5. Okay, so here's the question. How do I know whether it's the positive one or the negative one? And that's specifically why I like to draw a picture. All right, because cosine is positive in the first and in the fourth quadrant, but cosine is negative over here in the second and in the third quadrant. So if the angle is going to be acute and we need to have a cosine value, it's going to have to be the positive one. All right, so that's why we can just say, find with finality that the cosine of the angle is 4/5. Okay, let's try this one. Okay, now again, this one we are solving. Okay, that means in the end, I want to know exactly what theta equals. And they give me a limit here. I can only find values between 0 and 2 pi. Okay, so I'm in one full rotation about the circle. Now, the first thing that's sort of jumping out at me on this problem is that over here I've got cosine and over here I have sine. Okay, that's kind of a problem. It's hard to solve an equation with 2 different variables. In other words, I mean, I know that I'm solving for theta, but it'd be easier if it was all in terms of sine or all in terms of cosine. So if you manipulate one of the big kahunas, okay, in fact, the number 1 big kahuna, you can write sine squared as 1 minus cosine squared. All right, so now if I just distribute, right, and I move everything to one side and collect my like terms and set it equal to 0, I get 2 cosine theta plus cosine theta minus 1 equals 0. Okay, and this factors. Okay, this factors actually beautifully to be 2 cosine theta minus 1 and this to be cosine theta plus 1. And if I set each of those equal to 0, the first parentheses will give me cosine of theta equals 1/2, and the second one will give me cosine theta equals -1. Okay, now again, I'm hoping you have your unit circle somewhere near you. Feel free to use it, because the cosine equals 1/2 in two different places. It happens in the first quadrant at pi over 3, and it happens in the fourth quadrant at 5 pi over 3. And the cosine of an angle that equals -1 happens one place on the circle at pi. Okay, so this particular problem has 3 different answers. Okay, now notice the difference here. This one is saying to simplify, meaning we're not solving for anything. We are just trying to simplify, and you will know that it's simplified if you can get it down to either a single number, right, a number, or a single trig function. Okay, so I'm noticing that this has 2 terms, okay, 1, 2, and those 2 terms have a common factor of sine squared. So if I factor that out, it looks something like this. And then if you look at your big kahunas, this is actually secant, which I should have not written right there. There we go. Sine squared of x times the secant squared of x. All right, and again, this is equal to something else. It is equal to 1 over the cosine squared. If I multiply these two together, I get sine squared of x over cosine squared of x, which is a single trig function, tangent squared of x. Okay, this is one of my favorite problems. Again, it does say simplify, and right now there are 3 different, I'm sorry, I'm lying. There are 4 different trig functions in there. I see sines, I see cosines, I see tangents, I see cotangents, right? There's a lot of stuff to deal with in there. So, whoa. So let's see what I can do with this thing. So I'm going to write everything out that I possibly can in terms of sines and cosines. Okay, I'm going to do this stuff over here on the left, and I'm going to do this stuff over on the right. So looking at this, I know that that's 3 cosine betas. And that this is sine over cosine. And then don't forget this guy. Okay, so I've just sort of expanded everything out. Over here on the right, this is 3 sines of beta over a cosine beta. And then the cotangent is cosine beta over sine beta. Now this is what's cool about this problem, is that the sines cancel here, the sines cancel here, a cosine cancels here, and a cosine cancels here. So when I multiply what I have left, over here I've got cosine squared beta, and over here I've got sine squared beta, and that is, ladies and gentlemen, the big kahuna. This problem equals 1. All right, and then my last example here. If I distribute the tangent here, I would get tangent squared of alpha. When I distribute here, something times its reciprocal, that just equals 1. And again, keep looking back at those big kahuna formulas, because this equals the secant squared.